All right, thank you for joining us today. And in this video, this is an exam 2 from UIC Calculus for Business that we are going to go through, right? So we've done the review 1, review 2. We want to take this exam, see how the questions are being put and how you can also solve it and how you are expected to, provide the solutions, right? So let's get through this and see. So the first one is we want to find derivative of the functions below, right? So the first thing that we need to do is we find the derivative and we put our final answer in this box here, right? So what are we going to do now? We have y to be equal to this. So we are going to use the product rule, right? So let's assume that this is equal to AB, right? So what is A? Let's assume that A is equal to 10x squared and B is equal to, let's say, EX. Now what is A prime? When I differentiate A prime, I factor 10 out. When I differentiate x squared, I'm going to have 2x. So this is going to give us 20x, right? Then what is B prime? We said when you are differentiating an exponential function, maintain the function, then differentiate the power, right? So the power is x, and this is going to give us e times 1, which is the same as e, x. So now, what is the product rule? Y prime should be a b prime plus b a prime. So any of them, you can just do it straight and go. So what is a? This is a. What is b prime? This is b prime. So we are going to have 10x squared ex plus, what is b? This is b. What is a prime? This is a prime. So we are going to have ex times 20x. I can simplify this and write it like 10x squared ex plus 20x ex. So this is my final solution. So what am I going to do? I'm going to write it here. 10x squared ex plus 20x ex. So this will be the derivative for the first question. Let's look at this one too. So this one, we are going to use the quotient rule. So u divided by vn, what are we going to get? My u is equal to x, meaning that u prime is 1. What is vn? Vn is equal to x squared plus 3. What is vn prime? Vn prime is going to give us 2x. So we know that y prime is equal to vn u prime minus u vn prime divided by vn squared, right? So what am I going to do? This is going to be equal to vn is x squared plus 3. What is u prime? 1 minus what is u? U is x, and what is vn prime? 2x, all divided by vn squared, what is x squared plus 3 all squared. So let's simplify. When I multiply 1 through here, I'm going to have x squared plus 3 minus 2x squared divided by x squared plus 3 all squared. Now, final simplification that I do is, this is 1, this is also 2. So I'm going to have final simplification to be 3 minus x squared divided by x squared plus 3 all squared. So this will be my final answer. So I'll write it here. 3 minus x squared divided by x squared plus 3. Right, all squared. Good. Now, it's always good for you to do, let's say, this, right? Let's assume that, you see, I nearly forget the minus the 2 here. So that when we are marking, right, let's assume that I see your solution here, and even your answer is wrong, I can just go through your steps here and give you some marks, instead of just watching the thing and just writing the answer here. When you finish, don't clean the solution, so that if this one is wrong, we can allocate some marks to maybe something that you were doing right. Now let's look at C. Y is equal to ln of 4x minus 9x squared. Now, what is the process of differentiating a ln function? We are saying that 1 over what is inside the parenthesis, all times the derivative of what is inside the parenthesis, right? So 4x minus 9x squared. So what will be y prime? 1 divided by 4x minus 9x squared times, when I differentiate what is inside the parenthesis, I'm going to have 4 minus 18x. So finally, I'm going to have 4 minus 18x divided by 4x minus 9x squared. So I'll plug my answer here. 4 minus 18x divided by 4x minus 9x squared. Now, if you can also see it, this one I can just see it when I differentiate this on the top and then I divide it by what is inside the parenthesis. You can also do it straight and get the final result. But always do it in such a way that you get the right answer before you put it inside the box there. Now, let's look at another derivative here. So as I said, anytime you have a radical, or the first thing that you need to do is you change it to this form. Good. So now I was able to change it to this form. Then now I can find for y prime. So using the change rule, 1 over 2 drops down. I maintain the whole function, which is 3x plus 2x squared 1 over 2. But I'm going to subtract 1 because we are applying the power rule there. Then now I will multiply this one by the derivative of what is inside the parenthesis, which is 3x plus 2x squared. So let's do the simplification. We are going to have 1 over 2, 1 over 2, 3x plus 2x squared. This is going to give us minus 1 over 2 times. When I differentiate this, I'm going to have 3 plus 4x. So when I simplify this, this can be written as 1 over 2. Then I want to bring this one first. So I'm going to have 3 plus 4x, then 3x plus 2x squared minus 1 over 2. I just want to leave my answer in this form. So I just write 1 over 2, 3 plus 4x times 3x plus 2x squared minus 1 over 2. So this is what I'm going to get at the end of the day. Let's look at this one. This one too, we are using the product rule. So let's pick A, let's pick B. What is A? A is x to the power 5. B should be e to the power 7. So what is A prime? A prime is going to be 5x to the power 4. What is B prime? Now B prime, I maintain the function. I differentiate what is on the top, which is 7x. This is going to be give us times 7, and this is 7ex. So this is the process. So now what is y prime? A prime or AB prime plus BA prime. So what is A? A is here. What is B? B is also here. B prime is also here. 7 e to the power 7x plus what is B? B is e to the power 7. What is A prime? A prime is 5x to the power 4. Simplify, we get 7x to the power 5 e to the power 7 plus, when I multiply this one, I have 5x to the power 4 e to the power 7x. So I write my final answer here, 7, 5 here, e to the power 7x plus 5x to the power 4 e to the power 7. So this is what I'm going to also get for the one. So we are done with question 1. Question 1 was 5 questions. So we are done with finding the derivative. The next question here is to find y prime prime. Do not simplify your final answer, right? So here, because we have this one here, let's take the derivative. Y is equal to x to the power 3 plus 8 e to the power 2x. So we want y prime prime. So let's go for the first one. Y prime, using the power rule for this one, we are going to have 3x squared plus 8 out. When I differentiate e to the power x, what am I going to get? E to the power 2x times, then I'll differentiate what is on the top. I'll write it straight. So we are going to have 2, right? And then when I simplify, I'm going to have 3x squared plus 16 e 2x, right? So I maintain this function and differentiate what is on the top, which is giving us 2. Then now what is y prime prime? Now I need to differentiate my final results here. So when I factor 3 out and differentiate x squared, what am I going to get? 2x plus, I factor 16 out, differentiate e to the power 2x, maintain e to the power 2x, and differentiate e to the power 2x, which is going to give us 2. So our final result is going to be 6x plus 32 e to the power 2x. This will be the final results. from this. Right. This. So this is what I'm going to get for question 2. Let's look at question 7, question 3. So we have 7 questions. The first question here is asking us to find for the critical values, right? For the critical values. But it's saying that here we need to justify your answer B and C with the sign diagram. So the B and C, you will see that we will draw the sign diagram. So for the critical values, that is when f prime of x is equal to 0, right? So what you are going to do is now we need f prime of x before we put it to 0. So let's use the power rule to do that. So when I differentiate 3x x to the power 3, I'll have 3x squared. So 2 out, I differentiate x cubed, I get 3x squared plus 9 out. When I differentiate x squared, I get 2x minus 24 out. When I differentiate x, I get 1. And when I differentiate 10, I get 0. So when I simplify this, I'm going to have 6x squared plus 18x minus 24. Can 6 divide this, and that? Yes, I think so. 6 can divide this one 3 and divide this one 4. So we can factor 6 out. So 6 out, we'll be left with x squared plus 3x minus 4. So now let's find the factors. So factors of 4 will be 1, 2, and 4 itself, but we can use 1 and 4 to give us this. So what you are going to do is this is the same as x squared plus minus x plus 4x minus 4. So minus 1 times 4 is going to give us this. Then minus 1x, this one is going to give us 3x. So now we can write this one as 6. And then when I factor s out, this one will be x minus 1. Plus here, when I factor 4 out, I'll have x minus 1. Good. So here, I was just combining this. I factor s out and get this. This one I factor 4 out and get this. Since I have x minus 1, I can combine this one as 6, x minus 1. Then I combine the x and the 4, which is going to give us x plus 4. So with this simplification, it will help us to know the values of x that is going to make this f prime to be 0. So when x is 1, this will be 0. When x is minus 4, this one too is going to be 0. Or we can say that equate 6x minus 1, x plus 4 to 0. First, I need to divide 2 by 6. So I'll have this. Then x minus 1 is equal to 0. X should be equal to 1. Then x plus 4 should be equal to 0. X should be equal to minus 4. So the critical values of f is x is equal to minus 4 and 1. These are the critical values. This critical values is going to help us to solve B and also solve the C, right? So B, we want to find increasing and decreasing, but we need the sign diagram or the sign chart before we can do that. So let's put it on the sign chart and see. So I put my sign chart here, minus 4 and 1, right? Don't forget, with the sign chart, we use f prime of x. So we need to pick a value here, which is like -5, plug it inside the word f prime. Pick any value here, like 0, and plug it in, and pick any value here, which is also 2, and plug it in. So what is f prime? Good. Fortunate for us, we have f prime of x to be equal to what is here. So we want to check the sign, whether positive or negative. So let's plug in -5. So -5 minus 1 is going to give us -6. So it means that here will be minus. Then when I plug in -5 plus this one is also going to give us minus. So minus is going to be positive. So this one will be greater than 0. So positive here, meaning that we are going to increase in this interval. Now let's look at 0. When I plug in 0 here, I'm going to have negative. When I plug in negative here, I'm going to have positive. So negative times positive is going to give us negative. So this one is going to be negative and it's going to be decreasing. So we are going to have something like less than 0, right? Less than 0. Then let's look at the last one. The last one here is 1. So 1, the value here is 2. Let's plug in 2. When I plug in 2 here, 2 minus 1 is going to be positive. This one is going to be positive. Positive, positive will be greater than 0. So this one will be positive. Also what? Increasing. So what are the increasing interval? We have this, and the decreasing interval will be this. So increasing intervals will be from minus infinity up to minus 4, and then from 1 to positive infinity, right? This is where it is increasing. And for the decreasing interval, you are going to have minus 4 and 1, right? So this is what we are going to also get, right? So that will be the B. So we are using the sign chart to do that. Then for classify each critical value as a local maximum or local minimum. So or neither. So local maximum, local minimum. So what is the local maximum here? So local maximum is when you are using the sign chart and you see increasing and decreasing all together. So plus, minus. So this one is like concave down, which means that we are going to have a maximum here. So the value here is x. So here it is at the local maximum is at x is equal to minus 4. And the minimum is when you have decreasing and increasing. That is minus first before positive. This one is positive before minus, and then minus before positive. So this one is at x is equal to 1. Very simple. So this is very simple. All right. Let's look at question 4. Question 4, we have this equation here. We want to find the slope of the tangent line. So as I said, anytime we want to find the slope or the gradient, the value here is x and y, right? And anytime we want to find the tangent line, equation of the tangent line, the value here becomes x1 and this one is y1. So don't forget. So let's find the slope. Slope is the y over the x. So we are using this one. So x squared y minus y to the power 3 is equal to minus 6. Implicit differentiation. So let's go through that. This is product rule. I'll do it straight. Maintain x squared, differentiate y with respect to x. We are going to get dy over dx plus. Now maintain y, differentiate x squared. What do you get? 2x. Since we are differentiating with respect to x, we are not going to multiply by dx over dx because dx over dx is 1. Minus differentiate y to the power 3, you get 3y squared dy over dx. Differentiate minus 6 and we get 0. So we are done with the hard work. All we just need to do is now we just do substitution and we find for dy over dx. So let's plug them in. X is 2, so 2 squared dy over dx plus y is 1 times 2 is x is 2 minus 3 times y is 1 squared dy over dx equal to 0. So this is going to give us 4 dy over dx and then plus 4 minus 3 dy over dx is equal to 0. This implies that now 4 minus 3, because they are all with dx, is going to give us 1. So you are going to have dy over dx plus 4 is equal to 0. I add 4 here, I add 4 here. Sorry, subtract 4, and I'm going to have dy over dx to be equal to minus 4. So this is the hard work for B, because B is just substitution, because we know the slope. That's the hard work. So we are done with the hard work. B says that what's the equation of the tangent line? So we know that y minus y1 is equal to mx minus x1. So the slope is the same as dy over the x. So this is the same as the slope. We know x1, we know y1. So just substitution and we are done. So y minus 1 is equal to m is minus 4, x minus 2, and we are done with the slope. So the hard work was A. The bonus is B. So you do the hard work, then you get the bonus. Now let's look at question 5. Okay, so we need to complete this. So if f prime prime of A is positive, then f of s is concave up. Yeah, so this will be concave up. So whenever you are on the line, right, and then if you are on this side and this is prime prime, you get positive, this is concave up, right? So that is what we are trying to say. So whenever it is positive, it's up, and then automatically when it is negative, it will be concave down. Yeah, so that's what you are going to get for the B. So you just need to know C. Now consider the function and its derivative. So we have function, its derivatives, right? They are here. Now find the intervals where f is concave up. Justify your answer with the sign chart. Good. So with concave up that we are looking here, this one should even give you the clue. We always use the f prime prime, right? So this is the f prime prime. But with f prime prime, we need to have the point of inflection. At one say point of inflection, they are the values that make the f prime prime 0. Right. So let's look for them. So the first thing that we need to do is we need to equate this one to 0. The values of x that's going to make this one 0. So if we set this one to 0, then we can divide 2 by 12, right? Divide 2 by 12. So we are going to have x plus 8, x plus 4 to be equal to 0. X plus 8 is equal to 0, x should be equal to minus 8. X plus 4 is equal to 0, x should be equal to minus 4. So that's what you're going to get. So these are the point of inflection. Let's put them on the normal line. So minus 8 and then minus 4. Now we pick f prime prime of negative 9. Pick f prime prime of, we can pick like negative 5. Can pick f prime prime of negative 3. Then we are going to plug this one inside this. So that's what we are going to do. So let's check. When I plug negative 9 here, minus 9 and 8 is minus. Minus 9 and 4 is minus. Minus minus will be positive. So this one will be greater than 0. So this is going to be positive, increasing. Right. Let's pick negative 5. Negative 5 here will be plus. Negative 5 here will be minus. Minus, and this one will be negative. So we are going to have negative, decreasing. Good. So it means that this guy is less than 0. Then we pick negative 3. Negative 3 here is going to give us positive. Negative 3 here also going to give us positive. So here too is going to be positive, increasing, and this one will be greater than 0. So remember what we even did at A. Whenever it is positive, concave up. Whenever it is negative, concave down. So for the intervals, whether it is concave up or down, this is what you are going to get. For concave up, so concave, also the question is even asking us for just concave up. So we don't need to even think about concave down. So concave up, intervals is going to be the one which is increasing, right? So it's like they are where the increasing intervals are. So we are going to have from negative infinity up to minus 8, and then from minus 4 up to minus 4 up to positive infinity. So this is where the concave up is going to happen. Good. So that is question 5A, B, and C. So justify your answer with the sign chart. So always you need to draw the sign chart so that we can see the indication also there. Right. Let's look at question 6. We look at 7. We look at 7, then we are done. So question 7, we have the price demand function to be this. We want to find the elasticity function. So the first thing that we need to do is, what is the formula for finding this? It's minus P Q prime divided by Q. Don't forget Q is the same as f of P. Don't forget. So it's here, it's either you use E of P is equal to minus P f of P prime divided by f of P, or Q prime over Q. I'm using Q because they've given us Q here. So the hard work here is knowing this formula here, right? And then another hard work that we need to do here is finding Q prime. Okay, so let's find Q prime. Q is given here. So what is Q prime? When I differentiate 400, I'm going to get 0 minus 3. When I differentiate p squared, I'm going to get 2p. So this is going to give us minus 6p. We are done with the hard work. The rest is just substitution. So let's do substitution. Plug in minus 6p for Q prime and plug in this for Q. So we are going to have 400 minus 3p squared, and this is going to give us 6p divided by p squared divided by 400 minus p squared. So as I said, always don't cancel this and this. You cannot cancel because of this minus. You can only cancel when it's multiplying each other. So we are done. This is E of p. That is the elasticity function. Now we want to find it at p is equal to 10. So p is equal to 10. So what is E of 10? We just do substitution in this. So 6, 10 to the power 2 divided by 400 minus 3, 10 squared. This is going to be 6. 10 squared is 100 divided by 400 minus 3 times 100. So 600 divided by 400 minus 300. And we are going to have 600 divided by 100. And this is going to give us 6. Good. So that will be the elasticity at price 6. Now see for which price does an increase in price also increase revenue. So this is when we are at what? Inelastic. That is E of P is less than 1. Now what is E of P so that we can know that particular price, right? What is E of P? E of P is this. So 6 p squared divided by 400 minus 3p squared less than 1. So I just do substitution this by this because this is the same as EP. So that's what I'm going to get. So I just need to find for P. So I'm going to multiply both sides by the denominator, which is 400 minus 3p squared times 400 minus 3p squared. Now this cancel this. So it will be left with p squared, 6p squared. When I multiply 1 by this, I'll have minus 3p squared. I'm going to add plus 3p squared plus 3p squared on both sides. So 3 plus 6 plus 3 will be 9p squared less than this one. When I add, I'll get 400. Right. Good. I'll get 400. And then I'm going to divide through by 9. Divide through by 9. So we are going to have p squared because this will cancel this. And then I'm going to have less than 600 divided by 400 divided by 9. Then I take the square root on both sides. Take square root here, take square root here. I'm going to have p to be less than 400 divided by 9 square root. So all price that are less than this is going to what? Increase the revenue. That is the inelastic function. So now let's do the last question, which is question 7, and then we are done here. Now let's look at this one. Suppose we have the demand equation, which is this, and then X is the number of items produced, P is the price. We want to find the revenue function. So what is the revenue function? R of X is equal to X times price. So since this is X, our function here should be in terms of X. So we need to change the P. Fortunate for us, P is equal to 10 minus 0.2 X. So this is going to be X 10 minus 0.2 X. Simplify X minus 0.2 X squared. So there is no hard work. So this whole space is just for that. So since the space is too much, I can just do something like this so that I make use of the space here. Good, mathematically. So now if production for item is increasing at a rate at 10 items per week, so it means that since production is the X, that is the quantity, it means that since we are talking about increasing, that one will be the X over the T, which is equal to 10, right? Then how fast is the revenue increasing or decreasing? So increasing and decreasing would determine whether the revenue is going to be negative or positive. So what we are looking for is the R over what? The T. That's what we are looking for per week when 100 items are being produced. So that one will be X. X is equal to 100. So what we need to do, we need to pick this revenue function here and differentiate. So revenue is equal to 10x minus 0.2x squared. So what is the R over the T? When I differentiate, I bring the 10 out. When I differentiate x, what am I going to get? The x over the t, because this is with respect to t, minus when I bring 0.2 out and differentiate 2x, x squared, I'm going to get 2x dx over dt. Simplify 10 dx over dt. And when I multiply this one, I'm going to have 0.4x dx over dt. Fortunate for us, we have the x over the t to be 10 and x to be 100. So we can estimate the change in revenue. So this is 10 minus 0.4, 10 times, no, x is supposed to be 100. Yeah, and then the change is 10. So this is going to be 100 minus, this is going to, when I multiply this one, I'm going to have 40. So this is going to be 400, I think so, because this is 0. So 0.4 is like 4 divided by 10 times 100 times 10. So 10 will cancel 10. 4 times 100 is going to give us 400. So this is going to give us minus 300. So here it means that a change in the revenue is decreasing per week. We are going to decrease. So it means that here when we increase production, right, it means that the revenue too is going to decrease. It means that people are not going to buy a lot. So we are going to make the change in revenue is going to decrease. We are going to have negative. Yeah. So this is the end of the video for you. So if you have not go through all the questions in addition to do this one, and you'll be able to do the rest. See you in the next video. Oh, I didn't wish you all the best. All the best in your exams.